We have another example on the board. Again, we're supposed to raise the complex number expressed in polar form to power 1/3, fractional power. So what we're supposed to do? Again, we're supposed to use the following theorem. But remember, this time we are dealing with radians. So instead of 360 degrees, you're supposed to use 2 pi. So we have maximum value of k. K is equal p minus 1. Let me remind you, p is your denominator. So I have 3 minus 1 is equal to. This is the maximum value of k which I'm going to use in this formula. Okay, so I have to use values 0, 1, 2. I cannot use 3 because 2 is the max which I can use. So I have 435 raised to power 1/3, and I have angle 1/3 open parenthesis 2.83 radians plus 2 pi times 0. 0 because this is my first value of k which I'm supposed to use. This is equal 7.57. Of course, you're supposed to use the calculator. And angle of 0.943 radians. This is the first answer to my problem. If you want to find the next one, we have to find the next one, is 7.57. The magnitude is going to be always the same, and simply write 1/3 open parenthesis 2.83 radians plus 2 pi times 1 close parenthesis, and this is equal 7.57 and angle of 3.03 radians. Okay, so this is my second rule, second answer. If you want to find the third one, I have 7.57. The magnitude is always the same, and simply write angle 1/3 open parenthesis 2.83 plus 2 pi times 2. This is equal 7.57 and angle of 5.13 radians. Let me remind you, the denominator of my fractional exponent is telling you how many answers I'm going to have. I found 3 roots, so I can say that the problem is solved.